we are vectors. Today, new chapter, vectors we are starting. Now, vectors we know what is the definition of the vector and the scalar quantities you know. And you know what is the collinear, non-collinear, linearly independent, linearly dependent. We know. We know the laws of the parallelogram and the triangle. We know all things that we have discussed in the previous time. Today we are solving more questions on the vectors. Our first question is there, if the vectors AB minus 3i plus 4k and AC 5i minus 2k plus 4k and the sides of the ABC, then what is the length of the median through A? Now we are given the sides, two sides. He is asking the length of the median through A. Suppose ABC is a triangle. Suppose AB is a vector 3i plus 4k plus 4k. And AC is 5i minus 2j plus 4k. We are given this. Now he is asking the median through A. Suppose median is median. Suppose AC is median. Now we know the relation between the sides and the median. We know AB plus AC, we know is equal to twice AD. We know this formula. Put the value, you will get the AD, median, and get the magnitude, you will get the required solution. What is the length of the median? Now you see, AB is minus 3i plus 4k, we are putting the value. 5i minus 2j plus 4k is equal to twice AD. We know. What is here now? You see, here is 2i minus 2j and plus 8k is equal to twice AD. Now take the 2 common. This is the equation to the vector. In the vector form, the equation to the AD, median. We have the AD vector. The magnitude will be 1 square plus 1 square plus 4 square is equal to 18. This is the required solution to the equation number 1. Question number 1. Now we take the question number 2. If the vectors A and B are linearly independent is given, satisfying this relation. What is the most general value of theta? We are going to find we calculate the value of the theta. A and B are linearly independent. We know when the vectors A, B are independent and their sum is 0, then each should be equal to 0. Each should be equal to 0. We know this. Therefore, root 3 tan theta plus 1, root 3 tan theta plus 1 is equal to 0. Because the factors are linearly independent. Therefore, root 3 tan theta plus 1 is 0 and root 3 sec theta minus 2, root 3 sec theta minus 2 also 0. From these two, find out the value of the theta, which satisfying both. Now, here, from first equation we have 1 upon root 3, 10 minus 30. And we know this is minus. Therefore, this may be 360 degree minus 30 also. This is also value. And we have root 3 sec theta minus 2 is equal to 0. The sec theta is equal to 2 upon root 3. The theta is equal to again 30 degree. Theta is 30 degree or theta is equal to 360 minus 30 degree. We know this. We know this. The here lies in the fourth quadrant. The fourth quadrant where the sec theta or cos theta is positive and tan theta is negative. Therefore, the fourth value are this. Now, value of theta is 360 minus 30 is equal to 330. This is the value of the theta. We know the tan theta in the fourth quadrant is negative. Therefore, minus sign is removed when we put 360 minus 30. And similarly, the sec theta is also positive in the fourth quadrant. We can put theta is equal to 30 and theta is equal to this. But this is not satisfied with this. Not both are minus 30 here, plus 30, both are not equal, but the second value, they are equal, therefore theta will be 330. This is the answer, question number 2. Again I am repeating. The vectors are linearly independent, therefore the coefficient should be 0. Linearly independent, never 0. Their sum is never 0. If 0, then coefficient must be 0. You know this. Now therefore we have put the coefficient 0. We have the tan theta is equal to minus 30 and tan 360 minus 30. Both are satisfy this equation. First. Second equation is this. And both the values satisfy. But what is the common value to satisfy the both equation? That is this. We have this. This is the answer to the question number 2. We are now solving the question number 3. If the x, y are non-collinear vectors and ABC represent the sides of the triangle ABC, the satisfy a minus bx, b minus cy is equal to 0. Again here x y non-collinear means they are linearly independent. Vectors are x, y are linearly independent because they are non-collinear vectors. Therefore, x, y are the linearly independent. And the question number 3. Now, question number 3, we have x, y are linearly independent. Linearly independent. Therefore, coefficient is 0. Coefficient is 0 in both the cases. In 3 cases. Therefore, what we have in the question number 3, this is the xy non-collinear and ABC represents the sides of the triangle satisfying the triangle ABC. The A minus B should be 0, B minus C should be 0 and C minus A should be 0. Therefore, A minus B should be 0, B minus C should be 0, C minus A should be 0. We have A is equal to B is equal to C. We know then each angle is 60 degree. Hence, triangle is acute angle. Triangle is acute angle triangle. This is the solution to the question number 3. Because x, y are linearly independent. Because we are given we are given xy are non-collinear. Non-collinear, therefore they cannot be combined in same way. Therefore, these are linearly independent. Therefore, each coefficient must be 0. A minus b 0, b minus c 0, c minus a 0, which gives a is equal to b is equal to c. Means all sides are equal. Means all angles are equal. Means each angle is 60 degree. Hence the angle is acute angle triangle. This is the solution to the question number 3. Now we come to the question number. Now we come to the question number 4. X square 3y square is equal to 3. The equation of the ellipse in xy plane and B are 2 points whose position vectors are these. Then what is the position vector of the point P on the ellipse such that angle APB is equal to pi beta 4. Now take the xy plane ellipse, this ellipse, you know, question number 4, x square plus 3y square is equal to 3. This is the ellipse. Suppose this is the xy plane and this is x-axis. Here this is y like this. Suppose this is the z-axis. Z-axis. Z this. Suppose. Now the ellipse lies on the xy plane. Therefore ellipse is like this. Now here is suppose this is here is point lies minus 3 0 because we are given the xy plane where points are A and B, 2 points whose position vector minus root 3 and eta. Minus 3 eta. Therefore here is minus root 3 eta. Therefore this is 0. And the second point is given up to Z. Here say this is the A and this is the suppose B. And this is root 3 0 2. We have this, the point minus 3 0 2. We are given this. Then find out the point on the ellipse P. Suppose P is here on the ellipse, let it be xy. Now angle is given this A P B is equal to, this is pi beta 4. This is pi beta 4. Therefore AB upon AP we are given 10 pi beta 4. We are given this angle APB is equal to pi beta 4. We are given this. Therefore AB is equal to AP. AB is equal to AP we are given. We are taking the magnitude. Now what we are taking magnitude, we are going to find out the position vector of the P on the ellipse. Now what is the equation of the ellipse? This is. Now what is the point A? Minus root 3 0 0 and P is xy 0, xy 0. Here P is the xy 0 and B is minus root 3 0 2. We are given this. Now we are going to find out the value of the position vector of the P. Now find here point P. We find point P. What is the value of the P? You see here. Now we are given AB is equal to AP. Then I apply the formula AB minus root 3 minus x का स्क्वायर प्लस 0 माइनस 0 का स्क्वायर 0 माइनस y का स्क्वायर इज इक्वल टू root 3 3 का 0 and here 0 minus 2 का square. You see here. You see here. You see here. What we get? Here we will get 3 minus 2 root 3 plus 2 root 3 x plus x square. Here we get y square is equal to 4. Because here is only 0 2. 0 minus 2 matlab 4 square. This we get this. We have first relation this. And second relation is there, x square 3y square is equal to 3. Second is relation. From these two relations, second relation is this. Now first and two relation we find out the value of the coordinate of the p, x bar. What is the now? From put value from here, what we get? There you see 3y square is equal, put the value of the y square here. You see what is the value of the y square. We put the value, we have put the value of the y square 3 minus x square beta 3. Put this value in this relation. We have 3 2 root 3x plus x square plus 3 minus x square beta 3. We put the value of the y square is equal to 4. Now this is 9, this is 6 root 3. We take the LCM. Here root 3 plus x square minus 3 plus 3 minus x square is equal to 12. Now x square cancel out. And this is cancel out. Only we have 6 root 3x, 6 root 3x, this is the x. 6 root 3x we have plus 3. These are cancelled out, only we have this. What we get here? Here is 3x square plus we get 2x square only. Now take the 2x common. What we get? We have 3 root 3 plus 2x plus x is equal to, so x is equal to 0 and x is equal to minus 3 root 3. X is minus 3 root 3. Therefore, this does not lie on the ellipse. Therefore, because x square 3y square is 3. If we put this, then we have 27. Minus value comes in of the y. Therefore, this does not lie on the ellipse. This does not lie. Only this value we can put. As the value of the x is 0, value of the x is 0, I put in this, we get 3 y square is equal to 3, y square is equal to 1, y is equal to plus minus 1. Plus minus 1. The point P is here plus root 3 j. Y की वैल्यू है, only x j नहीं है. So this is j and 0. I lie on the xy plane. Lie on the xy Cartesian system. Therefore, this point is a root 1 j 0 0 1 j 0. This point is. Now, maybe here. This is here is minus. Here is plus. The 2 points are there on the ellipse. The point P is now P 0 root j 1 0 and 0 and 0 minus j 0. This is the position vector of the position vector of the P. Position vector will be this, point is this, 1 and minus 1. The position vector of is OP is plus minus j. Plus minus j. This is the answer to the question number 4. This is the question number 4. I'm again repeating. Suppose this is the ellipse in the Cartesian system, in the xy plane. And suppose zx is where this point lies. The second point lies this. This point lies. Suppose point is now root 3 and 0, 2. Now we are given AP is equal to pi beta 4. Therefore, we can say AB is equal to AP. AB is equal to AP, we can say. Now, apply the formula, you will have this. We have this. Now, we know from first and second relation, find out the value of the x and y. You see here, put the value of the y square, we get the value of the x. We have found out this. X is equal to 0 or x is equal to this. But this does not lie on ellipse. This does not lie. Does not lie on ellipse. This line outside the, away from the ellipse. He say P on the ellipse. He say, what is the position vector of the P on ellipse such that AP is pi beta 4. Now you so try to understand, not difficult, not try to understand. Now with the point A is this, and P is xy 0, and B is this. Here this AB upon AP 10 pi beta 4, therefore AB is equal to AP in magnitude. We apply the formula, we have the relation between x and y. We have also from the ellipse x square, 3y square 3. From these two relations, we find out the value of the x is equal to 0. And second is this, which does not lie on the ellipse. We have to leave it. Now take the value x 0 when we have y square is equal to 1 or y is equal to plus minus 1. Therefore, point 0, 1, 0 and 0 minus 1 lie on the ellipse. Therefore, position vector of the P will be this, plus minus j. Because x and y value are 0. This is the solution to the question number 4. Now we come to the question number 5. But vectors A and B are non-collinear. Again, given non-collinear means linearly independent. If the vector C this and this are the collinear, this and this are collinear, then what is the value of the 1 upon x? We are given A and B are non-collinear, but we are given this is collinear. These are collinear. Therefore, they can be combined C lambda B, C lambda D. We can combine because given vector C and D are collinear. We are here given C and D are collinear. Therefore, C is lambda times D. So we have they can be combined collinear. We are given collinear. Therefore, they can be combined with the lambda relation, with the constant relation. They can be combined. We are doing this. Now put the value of C. What is the value of the C? Here you see the C is given x minus 2a and b. X minus 2a plus b. X minus 2a plus b. And what is the value of the d? You see this is lambda times d is what is the d now? You see here, what is the d here? 2x plus 1. 2x plus 1, 2x plus 1, 2x plus 1 a, we are given this, minus b. We are given this. Now compare the coefficient of the A vector, what we get? We have x minus 2 is equal to lambda times 2x plus 1. We have this. Now second relation, here is 1, here is lambda minus lambda b. From this, we have lambda is equal to minus 1. From this relation, we have lambda is equal to minus 1. Now we have completed the coefficient of the b is here 1, here is minus lambda, therefore lambda is equal to minus 1. Put down lambda is equal to minus 1, we will get the value of the x. We will get the value of the x and we will put the value, we will get the answer. The put x lambda is equal to minus 1. Therefore, we have this minus 2x minus 1. This will give 3x, this will give 1. So x is equal to 1 by 3. The value of the 1 upon x will be 3. This is the required answer. This is the required answer. Now I am again repeating. Now we are given a C and D are collinear. We are given vectors A, B are non-collinear. We are given C and D are collinear. Then what is the value of the x? If these are collinear, then they can be combined. They can be combined. Then this is equal to lambda times of this. Put the value and compare the coefficient of the vectors A and B, we will have this. Put the value, we will compare the coefficient of the A, here is x minus 2, here is this. Here is B का coefficient 1 है, here minus lambda है, therefore lambda is equal to minus 1. Put the value here, we will get the value of the x 1 by 3. Or value of the 1 upon x is 3. Now this is the solution. So these chapters are very easy. Vectors, differential equation, the three-dimensional geometry, differential equation. These vectors are easy. The student can get more marks if they solve with the honestly or with the labor, they solve these questions, then the student may get more and more marks. Now we come to the question number 6. ABCD is the tetrahedron. O is any point if the line joining O to the vectors meets the opposite faces at P, Q, R, S respectively, then what is the value of the OP beta AP, OQ upon BQ, OR upon CR upon DS? We are going to find out. Number 6. ABCD tetrahedron at any point if the line joining O to the vertices of the vertices meets the opposite faces at P, Q, R, S respectively. What is the value of the OP upon AP, OQ upon BQ, OR upon CR, OS upon DS? Now you see here, tetrahedron, ABCD is given as a tetrahedron. A, B, C, D. Suppose tetrahedron. Suppose O is any point. Therefore, we join this. Now, suppose suppose the position vector of ABCD are A and B and C and D. Suppose the position vector of capital A, capital B, capital C, capital D are A, B, C and D. Suppose. Now, after these are the vectors with the O are linear independent. Linear dependent, then they are scalar quantity, there exists scalar x, y, z, t such that x a plus y b plus c z plus d t dt is equal to 0. We know this. If the vectors are A, B, C, D linearly dependent, then we can put this. Linearity, their sum is 0 for the linear dependent vectors. But for the linear independent, if this is 0, then it must be 0. We know this. But this here is linearly dependent. Therefore, we have this. Therefore, we have this is equal to minus xa. Minus xa. We have this. Now here lies a BCD. Suppose BCD lies on this plane BCD. Suppose BCD lie on this plane, then we are divide this by YZT. Here also we divide scalar YZ plus T. We can put this. Now the line, the point on this left hand side, this and this, shows that the point lies on the OA line and the BCD, the other have a common value. Therefore, we can say the OB is here, P lies on the face. OB is here minus xa upon y plus z plus t. These are scalar. This lies on the OB, common point. Now we know, now AB is equal to OB minus OA. We know this. The AB is equal to OB, we have put this YZ plus T. OA we can have this. Now take the common A. We have X, Y plus Z plus T. We have this value of the A. We can AB is equal to minus x plus y plus z plus t upon y plus z plus t. This is the value of the A. Now put the value of the A here. Now AB into yz plus t upon the minus x plus y plus z plus t. This is the value of the A. Put here. Then what we get? OB is equal to this you see here. AP into y plus z plus t, minus will cancel out. We have only value of, we have only this. X plus y plus z plus t. We have this. Putting the value of the A, this, we have this and the yz plus t. Yz plus t. This will cancel out. Minus cancel out. We have only OP is equal to AP, this will cancel out, we have this only. This is the, now this is the value of the AP is 1 upon x plus y plus z. Here is it, x also, x also, here you see, here is x also, therefore we have x here, here is also x, we have this value of OP upon AP, we find this. Now similarly we can find out OQ upon BQ, same y beta x plus y plus z plus t. We will find again value of OR upon CR, z upon x plus y plus z plus t. Similarly, OS upon DS, we will find the T upon X plus Y plus Z plus T. All OP upon AP plus OQ upon BQ plus OR upon CR plus OS upon DS is equal to what? What will, we have the same thing x plus y plus z plus t. On the numerator, denominator also like this, therefore we have value 1. We have value 1. This is the solution to the question number 4. Question number 6. Question number 6. This is the value. Question number 6. Again I am repeating. Now we are given the position vector of the ABCD, AB, suppose. Now they are linearly dependent. Therefore we can put then in this form. We can put where x, y, z, t are scalars. We can put this in this form because they are linearly dependent. Therefore, we divide this, we have this value. Now, we line OA and on the plane BCD, they have both a common point. Therefore, the OP is this and BCD is this given by this. From the left hand side and right hand side, you see OP is this. You see here. Now AP we know, OP minus OA, put the value of OP is this, O is equal to A, we get this. AP is equal to this. Put the value of here A. Find out the value of the A, this is value of the A, and put here, you will get OP is this, or OP is equal to this, you see. OP is equal to this. Now, OP is equal to AP into X upon X plus Y plus Z is T. Now, take the here in the denominator AP. In the denominator of the OP, you take the AP, we have this. Similarly, we can say OQ upon BQ this, OR upon CR Z upon this, and what this with this. And for these four, we will get this is equal to 1. This is the solution to the question number 6. Now we come to the last question. The vector contain a P and 1. Vector contain P and 1 component. Therefore, this is Pi and then J. With respect to rectangular axis, the axes are rotated. Therefore, vector will go away. Rotate will also rotate, but their magnitude will be remain same. But we say rotated through the angle alpha above origin anticlockwise direction in the opposite direction. The vector space component P plus 1 and 1. Here the component is changed. but the magnitude remain the same. The magnitude remain the same. If we rotate the axis, the magnitude will remain the same. The question number 7, the magnitude of vector is same, remains same, remains same. Now first magnitude is p square plus 1 square under the root. And second, what is the magnitude? P plus 1 square plus 1 square. The magnitudes remain the same because only the axis rotated. But we are given the magnitude component are changed. Here component, in the first case, component are P and 1. In the first case, they are component are P and 1. In the second case, the component are P plus 1 and 1. Component change. But the magnitude, remain always same. Therefore, put equal to its component both the cases, you will get the value of the P. You see here. Now, you solve this now. Here is P square plus 1, here P square plus 2P plus 1 plus 1. Therefore, the P square will cancel out. Here we get 2P plus 1. Here 1 cancel out. Then what is the value of the P? We will get the value of the P here. Magnitude remain the same. Magnitude remain the same. You know the magnitude here is P plus 1 and 1. And the component here is P and 1. Therefore, we have magnitude this and magnitude this. You see, the 1 cancel out, and only we have 2P is equal to plus 1, the 3P is equal to minus half. P comes minus half here. You see here, the value not minus 1, but P comes here minus half. About the origin, the clockwise direction, the P, he wants a P is equal to 1. Now, you see the component of this square plus this square, what we get? P square 2P plus 1, here we will get 1. So therefore, what is the value of P? We will get now what? We get this, 1 cancel out. Here we have P square 1. Here we get P square 2P plus 1 plus 1. Therefore, the P should be minus half. P should be minus half. This will cancel out. And 2P plus 1 is equal to 0. We get P is equal to minus half. Wrongly written. This is the 2. If wrongly we have put here, this is the 2. This is the 2. If this is the 2, suppose this is 2, suppose, then what we get? This we get 4P and 4, then 1 cancel out, P square cancel out, we have 4P plus 4, then we have P is equal to minus 1. So therefore, the component is P plus 2. It is only written here P plus 1. In the second case, the component should be P plus 2. We only written P plus 1. If P plus 2, we will have the value minus 1. If P plus 1, the value of the P will become minus half. This is the solution to the question number 7. We will take now tomorrow more questions on the vectors.